Welcome back to Human X Intelligent, the space where we'll explore how humans and machine learn, think, and shape each other. My name is Madalena Costa, and I'm your host. In part 1, we talked about what alignment really is and why intelligent systems often drift away from our intentions, not because they're too powerful, but because they become powerful in the wrong direction. Today, in part 2, we go deeper, not into the theory, but into the architecture. How do you actually design systems that stay on course? Because alignment isn't magic, it's design work, it's clarity work, it's intention work, it's loop work. So let's get into it, shall we? When systems drift, it rarely feels like something dramatic. It usually feels like things are moving just slightly in the wrong direction. And that happens for a few predictable reasons. It can happen because systems optimize for the easiest measurable signal and not always the signal that we are intending for them to do. Feedback loops are weakening very quietly, and we don't know what happened until it's too late. Incentives influence behavior more strongly than rules, and attention becomes fragmented across people, products, and model. And in multi-agent systems, even tiny issues can get amplified. And here's the part that's actually often overlooked. The more agency a system has, the less visible the drift becomes, until it's big enough that everyone notices. If we only think about alignment when something is already broken, we are not designing, we are reacting. So let's shift that mindset, shall we? Every system has a center of gravity, something it naturally lends towards, and that center is defined by incentives. For people, incentives change behavior, and for machines, incentives shape optimization. And if those incentives are misaligned, everything else will drift with them. Before building anything intelligent, I always ask these 3 questions. Number 1, what behavior do we actually want to encourage? Number 2, what signal represents that behavior and is it reliable? What unintended incentives might we be creating by accident because of a system that believes on engagement equals success? Well, it will be optimized for engagement, right? Even at the expense of clarity, trust, or usefulness. And that's often when drift begins. So, alignment systems don't happen accidentally, they're built intentionally on 4 components. Number 1, attention architecture, which starts with human attention, goes to product attention, and from product attention, it goes to model attention. If these aren't aligned, the experience starts to feel confusing or even unpredictable. Feedback loop integrity is number 2, which basically means that a system can learn from the quality and rhythm of the feedback when it's received. Number 3, explainability as part of the design, not as a compliance requirement, but as a usability principle. People trust what they understand, and teams can only improve what is visible to them. Number 4, and the last one, which is incentive clarity. If the system isn't rewarded for the behavior we want, it won't prioritize it. These 4 systems or 4 pieces form the foundation of an aligned system. There are also other things that we can think of, for example, the 5-step model to keep the systems actually aligned, which solves what we were talking about. The step 1 is pretty simple, which is just to map behavioral expectation. What should the system do? What shouldn't it do? And what does good behavior look like in context? These are the 3 core important for this map of behavior. Specifically on the shouldn't it do, because it can generate negative reinforcements or negative feedback from the users after it, and you can actually lose all the trust and lose the users, which will also decrease the ROI, which is not good for business. But this seems kind of obvious, right? Which is why people usually skip it. But AI doesn't forgive ambiguity. Number 2, which is like the step 2 of it, is the connection behavior from signal to adjustment. So every adaptive system relies on 3 elements: the behavior, the signal it produces, and the adjustment the model makes. If any of these are misaligned, drift begins. For example, and a very simple example, if a user behavior produces a signal that doesn't actually represent what we care about, the model learns the wrong thing, even if the metric looks good, which is not good at all and something that we need to take in consideration and actually do the three elements that I just told you in a few minutes before. Step 3, validate incentives. I use one simple question here. It's very simple. If I were an AI trying to maximize this metric, what behavior might I adopt that isn't what we intended? Which is surprisingly quickly to happen. Step 4, inspect the model attention, which is basically which features or tokens is the model relying on the most, and are those the ones we intended? A lot of drift happens at this level, quietly and gradually. Step 5, add explanation touchpoints, not long explanations, and sometimes even just a component reflective of or with an animation can actually solve it and you don't have to actually write it. It's basically just enough context for the user to understand what is happening. Things like, here's why you're seeing this, the system adjusted because we prioritized this due to risk reduction. We actually also went a little bit deep on this on the previous episodes because I think it's very important for us to understand that explanation doesn't need to be something that you write in a context space like I would just explain to you, but you actually can do it in a visual landscape that actually solves the problem in a much easier way and doesn't add more noise to the environment, to the screens, to everything that you're creating. Basically, when a system explains themselves, trust increases and drifts becomes visible much earlier. In every misaligned system, I evaluate the early indicators were already here. For example, users saying something feels off, that is a red flag that we should do something about. Teams saying, for example, it wasn't supposed to do that. That's something that is critical and something that we need to understand why that is happening. Did we forget to say what are the constraints, what are the guardrails, what happened in order for this to be the response? For example, also data scientists saying something like this metric looks fine, but something is strange, which most of the times it's something pretty simple to solve, but we forget because we don't pay attention. So it's good that the team overall pays attention to this and finds this problem even before it goes live or even before the users see it. Product notices, for example, we are spending more time fixing things than building, which kind of shows that maybe the planning, the structuring, the actual documentation for the AI that you're using is not working very well, or even for the product that you're building, something is missing. Is it the user testing? Is it something around the product description? Wherever it is having these issues. And this might be like minor issues, but they are early symptoms of the drift and something that we need to pay attention because if this keeps happening and these minor issues keep building up, they become a ball. They become a snowball, something that keeps on growing and growing until it bursts. And then it's too late to do something. Basically, when you hear them, the right move is not to optimize, it's to investigate. It's to find the core problem and find the solutions that will give the most positive to this drift to not to happen, basically. As we move into the systems with more agency, every turn becomes less linear. One agent drifts becomes another agent's input, and the misaligned propagates through the network. So when that happens, you get systems that appear intelligent but feel unstable or inconsistent. The solution is pretty simple in principle, harder in practice, as we all know. Shared incentives, shared attention, shared feedback rhythms. Agents don't need to agree on everything, but they do need to stay coherent with one another. So that's why it's important to understand multi-agent alignment and how this actually works in practice. But long-term alignment isn't about control, it's about coherence. Coherence basically means incentive match the intended outcome, feedback loops reinforce the right behavior, attention is aligned across humans, products, and models, explanation reduces uncertainty, drift becomes visible early and not late, which is very important to think about. And alignment is not a one-time task, it's an ongoing design practice. And as our systems become more intelligent, our alignment strategies have to evolve with them. This is part 2 of Alignment, a deeper look at how we keep intelligent systems on course as they gain more agency. Next episodes explores the architecture of attention because clarity doesn't start with communication, it actually starts with when we choose to look at. Thank you for listening to Human X Intelligent. If this episode gave you something to think about, share it with someone building in the age of agency and the age of AI. See you next Thursday.